In this video, we are going to be talking about ratios, and we will be going over a few things. First, just generally, what is a ratio? Then we will be talking about tape diagrams and how we use them to solve word problems involving ratios, and then finally, ratio rate tables. So first, let's just talk simply about what is a ratio. So before I explain a ratio, I'm going to talk about fractions. If I were to look at this rectangle here and write down how many or what fraction of the rectangle is shaded blue, I would say, well, there's 3 boxes out of the total 9 in the rectangle that are shaded blue. 3/9 of the rectangle is blue. So a ratio is really similar to a fraction. It's comparing two things. And it kind of, in a way, looks like a sideways fraction. So if I were to take this and just flip it on its side, this is a ratio. And we read this as 3/9, like this, 3/9. I'm comparing how many boxes are blue to how many there are total in the rectangle. And so another similarity between fractions and ratios is just like how I can reduce fractions. I can think, oh, if I have 3/9, I can divide the top by 3 and the bottom by 3 to get 1/3. The same is true with ratios. With this ratio 3/9, I can divide this side by 3, and so then I also divide this side by 3, and my new ratio is 1/3. So really similar in a lot of ways. I can compare some other things in this rectangle. For example, I can compare the number of blue boxes to the number of not blue boxes. So I would say for the number of blue boxes, there are 3 blue boxes, and then to the number of not blue boxes, well, there are 6 boxes that are not blue. So I have my ratio to represent this, 3/6. And so notice how I wrote it in this order, 3/6. If you were to write a ratio of this here, and you said the ratio is 6/3, this would not be right. Just like how 3/6 does not equal 6/3, these two ratios here are not equal. It's really important that you write it in the correct order. So how do you know the order to write it in? Well, you need to look at the problem and what it's telling you. So in this problem here, it tells me first, it says the number of blue boxes. So first, I will write how many blue boxes there are. Then it says the number of not blue boxes. So then I will write the number of not blue boxes. Now here are 3 example problems to try on your own. I have this picture here of this rectangle. I've divided it up into boxes and I've colored some of them in red. So your job is to write the ratio of red boxes to gray boxes, red boxes to total boxes, and total boxes to gray boxes. So just read carefully, pay attention to the order, and write down what these 3 ratios would be. So in a second you'll pause the video and do that, then play the video when you have your answers. Go ahead, pause the video now. These are the 3 answers that you should have gotten. There are 5 red boxes, 10 gray boxes, so I would say 5 to 10. And I can simplify this by dividing both sides by 5 to get 1/2. The next one, 5 to 15, or I can simplify to 1/3. Then the last one, 15 to 10, or simplified, 3 to 2. If you got any of these wrong, check your work, see where you went wrong, and fix your mistakes. Ratios are also involved in some word problems. Here's an example of a word problem that uses ratios. There are 3 white tiles for every 2 blue tiles. There are 30 tiles in all. Draw a picture to represent the problem. So I'm going to draw 30 tiles, and I can quickly do this by just making a rectangle, one big one, and dividing it into 30 parts. So I have 5 by 6, these 30. So it says there are 3 white tiles for every 2 blue tiles. So that means I'll have 3 white and then 2 blue. 3 white, 2 blue, 3 white, 2 blue, 3 white, 2 blue, 3 white, 2 blue, 3 white, 2 blue. So now I can see how many tiles are white. Well, I have 1, 2, 3 by 1, 2, 3, 4, 5, 6. 3 times 6 is 18 tiles. And how many tiles are blue? 1, 2 by 1, 2, 3, 4, 5, 6. 2 times 6 is 12 tiles. I can represent this with ratios. So I have 3 white tiles for 2 blue tiles. So I would have the same thing, 18 white tiles for 12 blue tiles, which you can see is equal to the first ratio because I multiply both sides by 6 to get the second ratio. So they're equal. Here's a similar problem for you to try now. So in a second, pause the video, read the problem, and solve. When you think you have the answer, play the video to check your answer. Go ahead and pause it now. These are the answers that you should have gotten. Your picture should look something like this, where 8 of the tiles are white and 16 of the tiles are blue. Before we move on to the next type of word problems, let's just do one more check-in. There are 5 girls and 10 boys. So write the ratio of girls to total kids, simplify this ratio that you get. What would this ratio equal as a fraction? And then simplify this fraction. So figure out what these 4 answers would be, pause the video, and then play it again to check your answers. These are the answers you should have gotten. 5 to 15, simplified would be 1 to 5. The fraction would be 5 over 15, simplified 1/3. One more thing, notice how I'm saying 5 to 15. So I would write this as 5 to 15. Not 5 and 15, 5 to 15. And remember, the order is important. If I said 15 to 5, nope, not right either. It needs to be this order. So pay careful attention to this. Now we're going to go over tape diagrams. Here's an example problem you might see. Mary has many markers. She has 2 fine tip markers for every 3 thick tip markers. She has a total of 30 markers. How many are fine tip markers? So there's one way I could solve this would be to draw this as a picture. I could draw a rectangle to help me represent this picture here. And then I would say, so 2 fine tip markers for every 3 thick tip markers. So 2 fine, 3 thick, 2 fine, 3 thick, and I keep going on just like this. fine, 3 thick, 2 fine, 3 thick. So then to answer the question, how many are fine tip markers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 fine tip markers. So this method here of solving the problem, it works, but there's a lot of writing and drawing involved. So I'm going to show you how to use a tape diagram. So to make a tape diagram, I first need to figure out what are the two units that I'm comparing. Well, I'm comparing fine tip markers and thick tip markers. And then I'm going to draw some boxes next to each of these units. To figure out how many boxes I draw, I need to think about the ratio of fine tip markers to thick tip markers. So it tells me here I have 2 fine for every 3 thick. So my ratio would be 2 to 3. So this 2 is for fine tip. So I'm going to draw 2 boxes next to fine tip. And the 3 is for thick tip. So I will draw 3 boxes next to thick tip. Then it tells me there is a total of 30 markers. So when I add up everything here, it's going to be 30 in total. So I'm going to be writing numbers inside of these boxes. To help me figure out the numbers that go in these boxes, it's helpful to know that whatever is in one box is going to be in all of them. All of the boxes will have the same number. So I have 1, 2, 3, 4, 5 boxes, and it adds up to 30. So I have the same number 5 times to equal 30. So something 5 times is 30. Well, I know this is 6. So inside every box, I will write a 6. So then I want to figure out how many are fine tip. So I'm going to figure out what's my total here just for fine tip. Well, I have 6 plus 6 is 12. So I get my answer, 12 fine tip markers. So both of these methods work. I would say this one is a little bit more efficient when you're getting up to bigger numbers. Like for example, if Mary had 1,000 markers, it would take you a really long time to draw a picture like this where you drew all 1,000 markers. It would be much faster to use this method here. So with the smaller numbers, this works too. They both work, but this one is much faster. Here's another problem to try on your own. So in a second, pause the video, solve it using a method we talked about on the slide before. When you think you have your answer, play the video again to check it. So go ahead, pause the video now. In the end, you should have gotten 12 dramas. So to solve this using a tape diagram, I'm comparing comedy and drama. My ratio is 1 comedy for 3 dramas. So I have 1 box next to comedy, 3 next to drama. I have 16 total. And so I add something up 4 times to equal 16. Well, 4 times 4 is 16. 4 goes in all the boxes. How many are dramas? 4 times 3 is 12. So 12 dramas should be your answer. Now we are going to move on to ratio rate tables. So these tables are really helpful to solve ratio problems such as this one. Ellen uses the same number of chocolate chips for each cookie. She made 4 cookies. She used 48 chocolate chips. So I'm going to make a table to help me solve this. Just like with the tape diagrams, I need to think about what are the 2 units that I'm comparing. In this problem, I'm comparing cookies and chocolate chips. So I will write them on top of each other like this, and I will create a table. And what do I know so far? She made 4 cookies, and this took 48 chocolate chips. So I will finish filling in the table as I need it, answering these questions. So the next one, how many chocolate chips in 1 cookie? So now if I have 1 cookie, I want to know how many chocolate chips does it take? So I need to think about the relationship between these here. So to get from 4 to 1, I need to divide by 4. So I will do the same down here. Divide by 4. 48 divided by 4 is 12. This is where knowing the math facts really comes in handy. So it takes 12 chocolate chips in each cookie. Then the next one, how many cookies with 60 chocolate chips? So the next thing I'll fill in is chocolate chips. There are 60. So let's think about the relationship from 12 to 60 times 5. So I'll do the same up here. 1 times 5 is 5. So 5 cookies. The next one, how many chocolate chips for 200 cookies? So 200 cookies, so I'll write the 200 up here with the cookies. And now I could go 5 to 200, what do I have to multiply? But personally, for me, it's a lot easier to think about it this way. From 1 to 200, I multiply by 200. So I will do the same down here. 12 times 200. So then if I'm not sure what that is, I can think about it this way. 12 times 2 is 24, and then I add these 2 zeros at the end. So it would be 2,400 chocolate chips. The next one, how many cookies with 144 chocolate chips? So I will make another column in my table, and I have 144 chocolate chips. So the 144 will go down here. So I personally think it's easiest to go from the 12 over here, because I know 12 times 12 is 144. So then I will go, if I'm looking at the 12, I'll go straight up and now use the 1 to compare. So if I did 12 times 12, then I will go up and do 1 times 12. And 1 times 12 gets me 12. So I would have 12 cookies. Then the last problem, how many chocolate chips with 62 cookies? So I will fill in another column here. I have 62 cookies, so the 62 will go in this row. And I personally think the easiest one to compare with 62 is 1, because I can pretty easily tell you that 1 times 62 equals 62. So then if I use the 1, I'm going to go down and use the 12. And then if I did times 62 on the top, I will do times 62 on the bottom. So now I will need to solve 12 times 62. 2 times 2 is 4, 2 times 1 is 2, 6 times 2 is 12, 6, 7, so I get 744. So you would use 744 chocolate chips with 62 cookies. Here is another problem for you to try on your own now. So you'll need to read the problem, then create a ratio rate table that you will fill in as you answer these questions down here. So once you solve it, you can play the video to check your answers again. So go ahead and pause the video now and solve these on your own. These are the answers that you should have gotten. The first one, 80 miles. then 4 hours, then 8,000 miles, then half of an hour or 30 minutes, and then 1,680 miles. So I filled in my table after I read each question. As I was going, I filled in the next column of the table. And notice how I tried to use colors to keep it really clear which one I was using, but notice how I always went back to this 1 here. This is probably the easiest one for me to use to solve each of these. If I have 100, well, 1 times 100 is 100. If I have 21, well, 1 times 21 is 21. Whatever I do to the one side of the table, I need to do to the other side of the table. And if I start off with this 1, then on the top, I always need to start with the 80. Or if I start with the 80, then I always need to start with the 1. I'm using the same column of the table to help me solve. So if you made any mistakes on any of these, go back to check your work and see where you made the mistake and how you could fix it. Hopefully now at this point you have a better understanding of ratios. We've learned a few different ways to solve them, and so hopefully you feel a little bit more confident now when you are solving problems involving ratios.